I'm not sure if here's anyone in this room who hasn't heard about the next company that will be presenting. But if so, just briefly, ENGEL is a huge company and is very well known globally for the production of injection molding machines and automatic solutions. Wiesinger, head of medical sales, will show us today how sustainability can also be shaped here. Keywords are energy efficiency, zero-defect strategy, and contact. I can't read my own. Injection molding. Sorry.
Thank you.
Compact automation cells. Now I have it.
All right. Thank you. Yeah, thank you very much for the introduction, and good morning also from my side. Yesterday we have learned a lot about resins, and I would like to use the next 20-25 minutes to show you what is necessary to produce also good parts with the good resin. First of all, let's have a short look on the agenda. I will start with some facts and figures about ENGEL, but very shortly. Then I will give you some insights of precision injection molding. And we have heard in the keynote from Mr. Seckler that energy efficiency on the injection molding side is very beneficial for our customers. So we have also solutions on that. Footprint optimizations is also very important for our customers, including automation cells, because usually in a production where plastic parts are produced, when cells are automated, then the automation takes a lot of space of the production. And then I will go to a bit more in the digital solutions. So for a zero-defect strategy and what we can do to make the whole production line a bit more efficient. And last but not least, I will give you an outlook on what we're working on. So in this picture, you can see our headquarters in Schwertberg. We're located in Upper Austria. It's very close to Linz. And as it's written above the picture, we are one of the leading injection molding machine manufacturers worldwide. But we see ourselves as the world market leader in creating customer values. Here are the facts about ENGEL. ENGEL was founded in the year 1945 by Ludwig Engel. We're still 100% family owned and in the fourth generation now. We have approximately 7,200 employees worldwide, and we were able to do a turnover in the last fiscal year of 1.6 billion euros. And the another two numbers, we're very proud of that, because ENGEL is investing a lot in their own facilities. Therefore, we invested over 500 million euros since the year 2018. And out of that 500 millions, there are 70 millions per year only in R&D. And a lot of these 70 millions is for digitalization since the last few years. Here an overview why we are seeing why ENGEL is not doing injection molding machines. Here you can see a scope of our products and services. So of course everyone knows ENGEL as a supplier for injection molding machines. But we can also deliver system solutions and robotics. So we have 3-axis robots, 6-axis robots, what we are manufacturing by our own. And what is very necessary for that round here is that we have a very huge plasticizing technology department. So we are doing all plasticizing components by ourselves. We have a lot of specialists for that, also for all kinds of resins what are able on the market or what are available on the market. Digital solutions and smart factory is also a big topic, because what we have learned in the past is that the process know-how on machine operators is going down. So we need to develop solutions how to have a good production and how to produce good parts. Process technology is an extension of the plasticizing technology. Therefore, we can also give a lot of support worldwide. And of course, global service and support is standard. So now let's have a look a bit more into the machine topic. Here you can see an overview of the ENGEL portfolio on machine side. ENGEL is able to provide a very wide range of injection molding machines. You can use different types, you can use different clamp forces from the smallest to the biggest, what is available on the market. But for the medical industry, these three types are mostly used. So on the left side, you're seeing our ENGEL e-Victory. This is the typerless machine, which is used often for clean room applications where you have problems with the sealing height. So without typers, it's very good to use that machine. To save a lot of energy and to be also very precise, you can use the ENGEL eMech, and this is the state-of-the-art medical machine from ENGEL. We're using that machine for 90% of all standard applications and for high performance applications, but this is mostly used for packaging applications with cycle times below than 2 seconds. Therefore, we use the ENGEL eMotion. For today, I took out the ENGEL eMech, and I will not go too deeply into the technical details, but just mention the most important ones. Why I choose the ENGEL eMech for this medical keynote? Because it's very compact, it's intelligent, and it's very efficient. And to combine that, machine controller, our CC300 is needed, because on that machine controller you can integrate a robot, you can integrate peripheral systems, etc. And for medical customers, the documentation is very important. And to document your whole process, it's necessary to have one controller, one data set, and so on. A medical machine must be very clean, because you can use the best resin, you can use the best machine, but when you have a machine which has a very high particle load, then you will have a problem at the end of the day and at the end with the quality of the part. Therefore, we have an encapsulated toggle on the machine. That means that there is no lubrication in the mold area of the machine, and so that makes the machine very clean and easy to use in medical environment. Why is this machine so energy efficiency? Here is a chart where we are comparing our own hydraulic machine with the control pump, and on the right green bar you can see the comparison with the ENGEL all-electric plus our energy efficiency package, where you are only using 33% of the energy of a hydraulic machine. And this is very low when you think about that you can run faster cycle times as well and can produce more parts in the same time. An all-electrical machine is also very precise. Electrical servo drive is doing always the same movement, and there is no big gap. And in our industry, everyone is talking about speed. Every production must be faster. But it's not the speed, it's the acceleration. And we are doing the dynamic on the eMech machine with a very high acceleration because we need to make sure that we can have a very fast speed in a very short way. And that's the main topic also on electrical injection units. We followed also our trend from our customers, and the trend is more parts on the same space in the production. Therefore, the mold cavities are increasing. That means the molds are getting bigger. But in the medical industry, the parts are mostly very small. So therefore, the clamp force is not, so a very high clamp force of the machine is not needed. We need space in the mold area. Therefore, we enlarged the taper distance, and by doing the makeover of our clamping unit, we also changed the geometry of the toggle so that the machine is getting shorter. That means for clean room applications, medical environments, you can use that machine type with a very small footprint and can produce more parts. A lot of cavities with small parts means also you have to check that you have a good balance in your mold. And the first topic to bring a good balance in the mold is to have a very homogeneous clamp force all over the platen. And otherwise you could have problems in the edges with some of your cavities, or you will have problems in the center. Depends on which mold type you're using, and of course of some process data. What about the footprint, including the automation? So what you can see here is a standard solution from ENGEL. So we are hearing to our customers and we are working out and developing the solutions. On this picture, you can see a robot mounted on top of the machine, and the conveyor belt is included, because free-falling parts are not very common in the medical industry. Most of the parts are taken out by a robot and are placed on a conveyor. A further development of that solution, what you have seen before, is that picture, because of course everyone wants to produce good parts, but what we are doing when one cavity in the mold has a problem and you are producing bad parts, usually you will recognize that very late. So a cavity separation could be very helpful. What we did is to include the cavity separation, and the cavity separation, to say that first, is not rocket science. It's simple and very often seen in production. But what is good to know here is that it's very compact, because it's integrated in the machine frame, it's integrated in the safety guarding of the machine. You can move it to the side and have again freely access to the mold area. And this is important for the machine operator. In case that they need to change the mold, then they need to go to the mold area on both sides and not only on one. Otherwise, they would have to build everything away, and this will take time. So here you can see a cavity separator, where also the cards with the bags are included and everything is fully automated. So you have a really very long time nothing to do. A further development of our automation cells, can you see here? This is our compact cell. It's not integrated in on the machine frame. It's a standalone version, but it's connected on electrical interfaces. And what's the idea of this? It is also on a very footprint saving. It's a very footprint saving solution where you can integrate a lot. You can use tray servers, you can use box transfer systems, you can use camera cooling stations, etc. This is also very compact, and you always need to imagine that in a medical industry, when the clean room is very expensive. So on a clean room, you're not calculating the square meters, you're calculating in cubic meters, because you're paying the air condition, etc. Therefore, also the height is very important. Therefore, such solutions with very low machines, very low automation, and also saving footprint is important. And what I have mentioned also before on our extended safety guarding is also possible here. So move everything out and freely access to the mold. So now let's go a bit more into the zero-defect strategy, because at the end of the day, when you're using a good resin and a good machine and you want to produce good parts, then you make sure that you will have the feedback from the machine that everything is fine, or even not. Therefore, ENGEL has a lot of digital assistant systems. You can see here an overview, and I choose 2 out of them for today because it's linked to the resin. And first of all, our IQ weight control. Our IQ weight control can compensate environmental influences on the material. And here you can see some pictures with possible influences on the process which makes process deviations. And process deviations are not needed in a medical process, because at the end of the day, we need to make sure that each part which goes to the patient is fine. A temperature can influence the viscosity of the material, for example, and IQ weight control can change that, so that we make sure that by each shot there is the same shot weight on the nozzle tip of the machine. And we are doing that by changing the switchover point and by changing the holding pressure during each injection process. And here I would like to show you an example. This is a part of a razor, and you can see here 2 charts where we are showing a comparison between using with IQ weight control and without IQ weight control. And as I have mentioned, the goal at the end of the day is to have always the same shot weight at the machine nozzle tip, so that for high cavity molds, you make sure that all parts are fully injected. And so that means what we did is we weighed always one shot in the parts. And on the lower diagram, you can see nearly a straight line, which shows that the fluctuations are not that high, and we reduced the changes and the range by 85% only by using IQ weight control. And this is just a software where you have to set a tick box and the machine is doing everything automatically. And when someone is asking for a validated process, also that is possible. We did several tests with customers, and a lot of very huge medical companies all over the world have validated their process by using IQ weight control, because you're setting the limits and the system is changing the process within the limits. Now let's go to another product what ENGEL is able to provide. This is our IQ process observer. As the name already says, we are observing our process. A machine, an injection molding machine, is collecting hundreds of parameters by each shot. We're talking about 600 to 1,000 parameters by each shot. No one can analyze that. This is not possible. The IQ process observer combines AI and the knowledge of our process experts. So we are able to visualize hundreds of parameters and to trend display in plain text. And how is this done? So first of all, I would like to go back a bit to the challenges. One of the challenges, the process itself. So 80% of the process engineers rely on their institution to solve quality problems. But the operator A and the operator B are different persons, so maybe no one knows if they are searching for the same problem the same way. So therefore, it's good when you have a system what is guiding you through that. The knowledge is not always on the same level, so therefore we can also give support to the machine operator. To look for an error, to look for a problem on the machine, it's time consuming. And of course, the impact of changes. When you're changing a parameter, no one knows what the parameter change is doing in the back. Maybe due to one change of a parameter, 3 other parameters are changing again. So transparency is the key. We need to make sure that your process is transparent and that you are able to set a good process and that you are fast when you're not having a good process. Because what we say with the IQ process observer, we're able also to control with parameter settings your part quality at the end. And that we know much earlier when there is a problem, because otherwise you would see it during your quality check maybe hours later. And this is not the goal of that. So what is the IQ process observer doing? We have automated process data analysis. We have a fast database fault diagnosis, easy to understand display, because usually hundreds of parameters, no one can do anything with that. There is no plain text, therefore we need to make sure you can understand the process parameters and what is the change. Then you can automatically set references, and the machine is coming back to you when there is a deviation. Hey, there is a problem, please look at this. Maybe you need to change that, and you are back on track. There is a guided root cause analysis, and of course, by using such a system, you are avoiding downtime and rejects. But now, a short outlook into the future and what's next. You have heard now some words about our IQ Process Observer, and as I have mentioned, the IQ Process Observer is making your process transparent. And when we are thinking a bit further, then a smart machine should be the target. As a first topic for a smart machine, there are 4 characteristics needed so that you can say, yeah, I have a smart machine. And the first one is connectivity. You need to connect to the machine, to your internet, you need to your network, so that you can use all these advantages. The machine must have a learning capability. Then you need to have adaptability. And at the end, an autonomous decision making, so that the machine knows itself what is to do. And with using our IQ Process Observer, you have the connectivity to your network, because we make it sure that the machine is connected and that IQ Process Observer can work with your process data. The learning capability is given, because the more machines are connected in your production, the more data can be collected, and the faster we are learning from your process and not from our processes. And then the adaptability, because as you can see here in this example, the decompression before plasticizing is too low. So the machine says to you, hey, please look at that, there we have a problem. And the own decision making of the machine is the fourth characteristics for a smart machine. So the IQ Process Observer creates a lot of transparency. And that is also very useful, because when you're not using IQ Process Observer and you are having a problem on one of your machine, as you can see it here, so maybe there is an alarm lamp, or you can see during your quality check that we have bad parts, but what's the problem? Then you're going to the machine and checking the problem. With IQ Process Observer, you're sitting on your master computer and you have connected all ENGEL machines to your master computer, so then you can see, hey, is my production fine or is it not? You can save machine operators in your production because you're sitting at your master computer and checking everything on the ENGEL machines. And now I would like to show a small roadmap, what was already necessary with the IQ Process Observer and what is hopefully necessary in the near future and what we're working on. Get ready for production is clear. Process optimization is possible. Process control is also possible with that. Quality control, this is something where we are working on, because at the end of the day, we want to have a self-regulating injection molding machine. And that would be very good, I think. And I hope you agree. Thank you very much.